Hello and welcome. Today's lesson is going to be about transformations. Okay, if you need a calculator, you can click right here on the calculator link and it will take you to the calculator. I myself am going to be using this calculator here on the side, and here is my notes. Okay, so what is transformations? Transformation is when we change a function, so that means they transforms from one function to another. Most of the time, when we're talking about quadratics, we use x squared, which is the parent function. So we most of the time we transform the parent function into something else. So we're going to look at some transformations today. We're going to start with reflections. Okay, so here we have f of x equals x squared was transformed to create the graph g of x equals negative x squared. So if you notice, this is the parent function, and this is the modify function where you have a negative in the front. So first thing we did is open the calculator and we plug it in the two formulas. Please notice that we used f of x and g of x instead of y, and that's okay. You can use y or f of x and g of x. The reason why I like to use f of x and g of x because it helps me understand the problem better and remember that this is the f and this is the g of x, okay? Also notice that the calculator do color schemes. So right there, you can see that the function f is the red function. This is our parent function. And the blue graph is your modify function, or the one that was transformed. Okay, so when you have a problem like this on the STAR test or any test, make sure you use your calculator. It's right there to help you. And when we look at this graph, we notice that this graph right here turned upside down. In mathematics, we call it a reflection because this graph is being reflected over the x-axis. In these problems, you're going to see that you're going to be asked what statements are true. So here we have two statements. The graph of G, which is the blue line, is a reflection of the graph of F across the x-axis. That's correct. The graph of G is a reflection of the graph of F across the y-axis. No, this graph did not reflect over the y-axis, but it did reflect over the x-axis, okay? Because right there is your x-axis. All right, let's go on to the next problem. The next problem is very similar. We start with the function f of x equals x squared and was transformed to create this new function g of x equals open parenthesis negative x close parenthesis squared. So if you notice, it's very similar to the previous problem where you had a negative, but in this time, we have a negative inside the parentheses and then raised to the square. So right there, we plug it in the two equations or the two functions. And when we plug it in the first one, the red one appeared. And then when we plug it in the second one, the blue one appeared. And this indicates that this blue line, okay, is a reflection of the red line over the y-axis. So basically what happened is this side of the red was turned to this side, and this side turned to that side. That means that was a reflection over the y-axis. So right there, we're going to click right there, okay? So please remember, if you have parentheses and a negative inside, this is going to mean that you have a reflection over the y-axis. If the negative is outside the parentheses or outside the x over here, so then you have a reflection over the x-axis. All right, let's go on to the next problem, problem number 3. We're going to talk about shifts, okay? Shifts is like when you shift the gear in your car, okay? You change the gear, okay? Well, in mathematics, you can have a shift that is going up or a shift that's going down or to the right or to the left, okay? So let's take a look over here. Here we start with the parent function and we add a 3 over here. So what did that do? Well, if you notice right there, the red line and the blue line, basically the blue line went up 3 units up. So we say that the graph of G, if you notice right there, graph of G is 3 units shifted up from graph F. So the letter C will be the correct one because the blue line is the result of shifting the red line 3 units up. Okay? And if you think about it, if this is positive and we went up, if it's negative, guess what happens? It goes down. Okay? And remember, your calculator is always there to help you, and you can see right there in the calculator that starting with the red line, we went down to the blue line, and what happened? It shifted down. So right there, we know the answer for this transformation is shifted down 3 units. Okay? Now let's say we have parentheses, and the plus 3 is inside the parentheses. Okay, whenever you have the parentheses, that means then your shift is going to be a horizontal shift. It's going to go from side to side. If it's positive 3, if you notice right here, what happened is we started with the parent function and we move 3 units to the left. So it's a little bit counterintuitive because you would think that positive 3, you go to the right, but in reality, we're going to go to the left. So right there, this would be letter B. And here we have a similar problem, but now we have a negative 3 inside the parenthesis. If inside the parenthesis, that means the movement is going to be horizontal and it's going to be counterintuitive. So that means instead of going to the left, we're going to go to the right 3. So that means this has been a shift to the right 3 units. So let's recap here a little bit. If you have a number outside of the parentheses being added or subtracted, if it's being added, the graph is going to shift up. If it's negative, it's going to shift down. If the number is inside the parentheses and it's positive, it's going to shift to the left. And if it's negative, it's going to shift to the right. All right? All right, let's now talk about the next topic, which is if the graph becomes wider or narrower, also meaning stretches or compressions. So let's see what that means. Here we have example number 7, and we start with the parent function, and it was transformed to create this new function with the 3 in front of the x squared. This number in front of the x is what we call coefficient. And whenever the coefficient here is bigger than 1, what happens is here you have your parent function, and when you apply this coefficient of 3, which is bigger than 1, the graph then, we call it stretches vertically, okay? It's like if you pull down this red line and you stretch, so it's much thinner from side to side. So in this situation, whenever you have a number here that is bigger than 1 and there's no parentheses, we say that there was a vertical stretch. Also notice that the graph became much narrower. So letter G, graph G became narrower than graph F. So right there, G is narrower than graph F. Now, if the coefficient that we put here in the front is less than 1, like 1/3, notice that the opposite occurs. Instead of them becoming narrower, it becomes wider. We also say instead of being stretched, instead of the red line being stretched, what happened is the red line is being compressed. It's like it's being squished. And when that happens, it kind of opens up on the sides. So, and you can see that with the calculator as well. So again, this is going to be a vertical compression, and the graph G became wider than the graph of F. Let's go on to the next problem. The next problem, now you have the parentheses and the coefficient being added in front of the x inside the parentheses. And because this is bigger than 1, then this is what we call a horizontal compression. Basically, it's like you squishing both sides, you're compressing both sides to form a narrower graph. So this would be a narrower graph, and this would be a horizontal compression. All right. And now the last example here is if the coefficient is inside the parentheses and is less than one, then what happens is the sides become wider. And this is what is called a horizontal stretch. It's like you pulling out these both sides. Okay, so this will be a horizontal stretch, and the graph G is becoming wider. Okay, let's go ahead and summarize. So basically, on this table here, we have the different transformations that we talked about. Over here is the function notation, and here's the using the example of the parent function x squared. So notice if we put the negative outside, we're going to get a reflection over the x-axis. If the negative is inside the parentheses raised to the square, then we have a reflection over the y-axis. So parentheses, y-axis, no parentheses, reflection over x-axis. Now let's talk about shift. If we don't have parentheses and we're adding or subtracting a number, then we're going to, if it's adding, we're going to shift up. And if it's negative, we're going to be shifting down. Now, if we do have parentheses, then the shift is horizontal. And it's kind of counterintuitive, meaning that if it's positive 3 here, then you should be expecting to have a shift to the left. And if it's negative 3 inside the parentheses or a negative number, you're going to be shifting to the right. Now, for the stretch and compression, okay, if there's no parentheses, is a vertical transformation. If it's a number bigger than 1, then you're going to have a vertical stretch, meaning that the graph is going to look narrower. Now, if the number or the coefficient is less than 1, then the graph is going to be a vertical compression, and the graph is going to look wider. Now, if we have a parenthesis, then you have a horizontal transformation. And if the number is bigger than 1, then we have a horizontal compression. In other words, the graph is looking narrower. And if the number is less than 1, then you have a horizontal stretch. You're supposed to say here horizontal. I'm sorry for my mistake there. Okay. And it's going to be wider. So I apologize here. If you have your paper notes, just go ahead and cross it out and put horizontal. Okay. All right. So let's go ahead and tackle some actual problems here. And this time we're going to use the calculator to help us. So right there, we start out with our parent function. So let's go ahead and write over here, f of x, close parenthesis, equals x raised to the square. And right there is our parent function. Now we're going to write the second equation, g of x equals, and this will be minus x plus 5 raised to the square. So right there, please remember that you have a calculator, and the calculator really helps you see the transformation. So right there, did we have a reflection? Yes, we did. And was it over the x-axis or the y-axis? Well, it was over the x-axis. So right there, we can cross that out. Shifts, okay? Did we shift vertically or horizontally? If you notice right there, there's your vertex, and the vertex didn't go up or down. It stayed right there in the same line. So there's no shift that was vertical, but the vertex did shift to the left. So that means there was a horizontal shift to the left. So right there, we have shift to the right, to the left, 5 units. There we go. We didn't go up nor down. Now let's talk about stretch and compression. So right here, if you notice right there, the graph looks pretty much the same as far as like how wide it is. And if you want to look at have a better look, you can see that it's pretty much the same opening. So there was no compression, no stretch. So in other words, the graph didn't become narrower nor wider. And you can see we already got a green light. So that means this is correct. All right. So now, just to illustrate here, if you notice right there, the negative means there was a reflection over the x-axis. The positive 5 inside the parentheses mean, remember, there's a horizontal shift. It's counterintuitive. So positive 5, you would think you go to the right, but actually it's go to the left. And that's exactly what happened there. It went to the left. All right, let's go to number 12. Let's go ahead and use a calculator. It's very quick and easy. All you have to do is erase there, punch it in, 2x squared minus 2. Whoops, made a mistake there, put a 2, and there we go. Okay, so now we see that here's our parent function, the red one and the blue one. First question is, do we have any reflection? They both look like smiley faces, so they do not reflect, so you can leave this blank. Did we reflect across the y-axis? Okay, if you remember, if there's no negative sign right there in front of the x squared, that means there was no reflection. Okay, so that's kind of confirms my suspicion there was no reflection. Now shift up or down. If you notice right there, the vertex did shift down 2 units. So there was a shift down 2 units. Okay, the vertex didn't go right or left, so there was no real shift left or right. So you can leave that blank. Now let's talk about stretch and compression. If you notice right there, the graph does look like the lines, the red became kind of squished and turns to the blue one. So in other words, the graph became narrower. So I know right there is letter K. All right. And when I look over here, there's no parentheses and there's a coefficient that is bigger than 1 in front of the x squared. So that means I have a vertical stretch. So vertical stretch would be right there. And there you go. Got a green light. Okay. So let's recap. Okay. The -2 means there was a translation or a shift down 2 units. There was no negative in front of here, so there was no reflection. And the coefficient in front of the 2x squared, the x squared, it was a 2, which is bigger than 1, so that means it's a vertical shift. And if you notice, the line became narrower. All right, let's go to problem number 13. Okay, please use the calculator. It can be your great help, okay, to help understand these types of problems and get the right answer. So let's go ahead and do there. Plus 4. Please double check that you write it correctly. So right there, I started with my parent function and I got into this one. So let's look for reflection. It doesn't look like it reflects because they're both smiley faces. I don't see any negatives here in the front, so no reflection. Okay, shifts. Okay, here's the vertex and here's the new vertex, and it seems that it shifted to the right 4 and then it shifted up 4. So it went right 4 and then up 4. And that's kind of confirmed right here because this means a vertical shift. It means goes up by 4. And in here, there's a horizontal shift, which is counterintuitive. So instead of going to the left, you go to the right 4. Okay. So that's kind of confirmed there. All right, let's talk about stretch and compression. I noticed there is a coefficient here, 1/4, but it's outside the parentheses. So that means it's going to be a vertical. Okay, now is it going to be a stretch or compression? Well, it's less than 1, So that means it's going to be a compression. Also, the other thing that you can look at is that the graph became wider. So that means that it got compressed. So the graph is wider. And there you go. That's all the answers we have here. Let's go on the last one. For this last one, let's do it on the reverse. Let's look at this and try to decide what kind of transformations happen, and then we're going to confirm by using the calculator. So right there, I see there's a negative, and the negative is outside the parentheses, so I know it's going to reflection across the x-axis. I also notice there is a coefficient outside of the parentheses, and that coefficient is bigger than 1. So that means I'm going to have a vertical stretch. Remember, if this number was inside, it would be a horizontal, and it would be a compression because the number is bigger than 1. All right, let's keep going. Inside this parenthesis, I have a positive 3, so this means there's going to be a horizontal shift, but it's counterintuitive, so that means instead of going to the right, I'm going to go to the left. So there is a shift to the left. All right, and then I have on negative 3 on the outside. That means I'm going to shift down 3. And one more thing is, because we did have a vertical stretch, remember that the graph becomes narrower. And there we go. We got the green light. Now let's confirm that using the calculator. So I'm showing you two things that you can do. You can look at the rules for the changes, and you can also look for your calculator to help you along. Okay? So don't forget that calculator. All right, so make sure you copy correctly. So according to my predictions, there was a reflection over the x-axis that did occur. There was a shift to the left, and it was 3 units, 1, 2, 3 to the left. And also I shifted down 3 units down, so that was confirmed. I also had a vertical stretch, so if I get rid of that keyboard right there, I can see that this graph looks much narrower than this one, so that matches letter K, and also that it looks like this graph was stretched. So there you go. So this concludes this notes for this lesson. I hope this video was helpful, and now you're going to be able to do the assignments. Have a great day. Thank you very much. Bye-bye.